the 1, you just get a what? U. Is everybody okay? That's going to give you a U when you integrate that. So it's going to give you 1/4 bracket U minus the natural log of what? U plus C. And then what do you do everywhere you have a U? You write in what? 2x plus 1 minus parentheses 2x plus 1. You've got to put absolute values around that one because it's not always going to be positive. And I'll go ahead and tell you the answer in the back of the book would look a little bit different. But let's make sure everyone's okay up to here. Anyone lost up to here need to wave your hand at me. Anyone? Is this doable for you? Yeah, as long as you write the U down out here. Now, here's what it looks like in the back of the book. Since the U is equal to 2x plus 1 minus natural log 2x plus 1 plus C. If you multiply that by 1/4, you get 1/2 x minus 1/4 natural log absolute value 2x plus 1 close parentheses plus C bar. These two C's are no longer equal. Because what I do, 1/2 times that is a what? A 1/4, right? That's just a constant. So what did I do with that constant? I just added it to that C and call it C bar. And that's where it gets nasty because your C, your C's out there. But this is what you would see in the back of the book. Anytime you have something with a constant added onto it, the back of the book won't have that constant added on. They just take that constant and do what? Add it into the C. So if you take the derivative of that, you'll get that. And it may not be easy, but you will. All right, one more and I'm going to collapse. You notice I'm spending more time on the ones that have too many x's than any of the ones that have too few. Someone says, Mr. Evans, if that was an x to the 4th, it'd be a real bad day. Okay? If that was an x to the 4th, this wouldn't work what we're doing. But you got to try what we're doing now. Because it will work for x to the 5th there. I think. I hope it does. All right? Rearrange it, put it in the right order, and then do your complete U substitution. And if this little method I'm showing you now doesn't work, like you can't get something that's easy to integrate from this, then you move to what's called trig substitution. And that's getting into trig. That's getting into integrals in the land of the beyond. Yeah, I'm letting y'all write for a minute before I write. I'm already anticipating something about my U. Hopefully y'all like this. And I will tell you what gets students in trouble is they get so used to the x's always matching up that they just say, oh, put a 2 there, 1/2, and then they just add and put the reciprocal up front. But you can't do that here because you got what? Way too many what? X's. Okay, so do your substitution and see what you get. Yes, sir?
How is u x squared plus 1?
It's not. It's x squared plus 4. Yes, sir. U is x squared plus 4. I'll do that part for you. I bet even my man that plans to never do math in his life can tell me how to get my du right.
How to get to du? You just put a 2 in front of that.
And if I put 2 there, what do I have to put out front?
A 1.
Man's thinking. Now you got to figure out what? X to the 4. Somebody tell me what I'm about to write right here.
X squared. Yeah. Which is u minus 4 squared.
Because x squared equals what? U minus 4. So I can do what? U minus 4, and then x to the 4th is what? X squared squared. Now, if you do that, in order to simplify it, use basic algebra. Multiply that, that's going to be u to the 5/2 minus u to 8u to the 3/2 plus 16u to the 1/2, all in parentheses du. You got it now into a polynomial of u du's. You use your rule, and you're on your way. That, and notice how hard that would be to take the derivative of it. That'd be a pretty nasty thing to just have to take the derivative of. Especially take the derivative and simplify it. But that's what you would get. Now, for those of you that aren't putting the integral sign out here, how many of you are not putting the integral sign out here? Mr. Bohr, are you putting that integral sign out there? Mr. Hermes, are you putting that integral sign out there?
Yes, sir.
You got to, folks, because you're not going to remember where you integrated if you don't put it out there. Because the step that you integrate on is when you lose that integral sign. And eventually there's going to be 2 or 3 of those little integral signs out there. So write it down. Okay. You get 1/2 bracket u to the 7/2, 2 sevenths, minus 8 u to the 5/2 times 2 fifths plus 16 u to the 3/2 times 2 thirds, close the brackets, plus c, and then you distribute out the 1/2 and change the u into what? X squared plus 4. And you get the final step. Now, I'm showing you a lot of these that have too many x's in them. Now, before you left for the holidays, I gave you a sheet that said, light hold the man. And now you can work everything on this sheet except for the trig. With what I have taught you today, you can work everything on here except for the trig. Okay? Work every odd problem on here except for the what? Trig. And you can actually work a little bit of the trig 21 through 28 from what I've already taught you. But Just don't work every odd problem on this page except for the what? Trig. Did anybody not get one? Did you, everybody, okay? You can work everything on there except for the ones that have trig. And this, folks, is a serious page. This is chapter 5 in a real college calculus textbook. So yeah, you're getting to the point where you're doing some real work. All right? Yes, sir.
I'm sorry, can you say again which ones we could do?
Every odd one except for the trig. And you can actually work 21 through 28 with trig. Because those are rules I've already taught you. Yeah. All right. That's Lighthold. That's the man.